what's up? This is day 3 in Math 3 for your factoring review. And I really enjoyed meeting with people today. If I haven't met with you, I will at some point. And here we go. So today is going to feel very much like a review. But now I'm going to add a couple bells and whistles on things because you have to know all the different types of cases. So I've kind of been working on general kinds of problems for you. But right now, I'm going to work on a problem where sometimes we make mistakes. So you're going to make sure that you put your name and pen at the top of the paper, and you're going to write out the problem and pause the video as you need, okay? So there are 4 terms, and at this point you really understand, hopefully, this idea of grouping. So I'm going to find the GCF out of the first 2 terms. So this is just going to feel old hat to you. I'm just going to factor this out on the top just to kind of remind you what we're doing. So 5 looks like it's common and 2 x's are common. So it's 5x squared. So that should feel just like the last one we did. Now the next one is the one we have to kind of keep our eye on. Right here. So these problems are set up so you don't have to rearrange, and the factor by grouping is most likely going to work. The problem is if you look at the first 2 terms, there's a plus sign, and if you look at the back 2 terms, there's a minus sign right here. It's not this necessarily that I care about, it's I'm checking to see, hey, what is this sign right here? Okay, so I'm going to have to factor a -1. And the reason why is because I do not have any greatest common factor between 5 and 1, but I do have this negative sign that I'm going to have to factor out so that this sign in the back changes. So now I'm going to go through and actually do the factoring. So I'm going to simplify things down. And then this becomes plus, forgot the square there, so I gotta make sure I have the square. And then this becomes 1, because 5 divided by 5 is 1. And when we factor out the negative on the second one here, this becomes positive 5x. And then a negative divided by a negative is positive 1. So you can now see the next GCF, which is the box, just like the previous assignment you did. So I'm going to put out the box here. And then I'm going to write what's left over. And write the box. And then we have it. So how does this problem differ from the previous problems? It's because we have this negative that we have to factor out. Now again, it doesn't matter if these are both negative. What matters is the second sign right here matches with the first set. So that looks pretty good. Oops. Okay, so you're going to see another example of this. So writing number 2 down. Hope you're following that 2-column format, unless you need extra space. And there were some people when I was grading your work that it was very clear you needed extra space, and I would rather you take the extra space. So if that's what you got to do, that's fine with me. Okay, there are 4 terms. We're going to try factor by grouping again. For some reason, I keep missing that square on the end. Okay, so this is 4, and then, of course, the x squared's canceled, and then we have the back here. So it looks like 5 is the common factor, so I'm going to divide a 5 out. Now, the question is, why am I not doing a negative? It's because when I look at this back sign right here, it matches with the first parentheses in the front of the first two terms. So I know that I'm not going to have to divide out any kind of negative or anything like that. So this is 5. And then I'm just going to simplify. And there's the minus sign right here. And so you can see now these two parentheses do in fact match again, because that's what our goal is in order to break this down by division. That's what factoring is. Remember, it's taking things apart. So now I've got these two parentheses right here that are exactly the same, so that's the GCF. And I didn't write the box on purpose that time. You should be leveling up at this point. So it's 4x squared, which is what's left over. And then you would definitely want to check this x squared to see if it factors, but it doesn't, so you're good. Okay, we've got another one here. So this one looks like it's pretty easy. It's really similar to what you did in the previous assignment. It has one slight difference. It looks easy though. Hope it does at least. I remember the square on this one, so that's good. And then 1 and 1, so there's a 1 back here. Now I'm going to rewrite the end of the problem, which I don't usually do. And there's a reason for it. So I haven't factored anything out the last two terms. But if you look at the factorization on the first two terms, you'll notice that the parentheses looks like the two terms that haven't been factored out yet. So what's happening is that in fact is the GCF, but what you have to be really careful about is that there's an invisible 1 right here, or you will not get it correct. Look at all those colors changing. There's an invisible 1, it's magical. So I'm gonna write the GCF out again. And then what's left? It's 4x squared, and then the magical 1 here. You would definitely want to check inside, can you factor? Well, no, because it's not the difference of squares because there's a plus sign, so it can't be difference, and so that is the end of the problem. So we are looking at special cases right now. Okay, so this looks like it will be pretty easy for you because it's the difference of squares. So the difference is minus, and then we have our perfect squares. So this is really important that you realize that the perfect squares look like this. And why is it important? Because tomorrow we're going to be looking at sum and difference of cubes. So this is a lot easier problem than what we're going to be looking at tomorrow. All right, so I've got everything factored. This is 4 squared, this is r squared, and this is 5 squared. So I'm good to go because I definitely have a difference. So it's 4r minus 5. And that should feel real comfortable to you. Okay, so v squared minus 9, that should be pretty easy, so go ahead and write that on your paper and do it on your own. I'll be looking for that when I'm looking at your notes. And then we get to a different type of problem. So go ahead and write this one down. It's not as obvious. Every time you do a factoring problem, you need to look for the greatest common factor. I don't care what type it is, you need to always look for it. That includes the problems we just did for grouping. Okay, I didn't talk about that very much, but No matter what kind of factor, always look for the greatest common factor. Okay, so when you're doing your interviews, that's actually something I'm going to be looking for. All right. Well, there's the difference, but up here, I can't write 32 as a perfect square. So I'm going to go, what is the GCF? And in this case, because both the 32 and 50 are even, I'm going to try to divide by 2. Or you'll see that there's a bigger number, but for right now, I will just start with that. So when I divide 32, I get 16. And then I'm hoping that all these will be perfect squares because then I can use the difference of squares. So I'm leveling up again. Okay, so then you're just going to factor what you have left. And I'm sure your number sense is amazing. People I've interviewed, it's been going really well as far as your number sense go. Very strong number sense. And that is it. So what is the difference? It's this 2 right here. If you don't have the 2, remember, you will only get half credit. So make sure you remember that GCF, okay? It's really, really important. All right, 7. So I keep talking about putting the polynomial in standard form and then looking for the negative sign out in the front, if there is one. So you're looking for, is there a GCF? And there is this time. In fact, I'll show you what it is. Okay, so hopefully you see right away that it is, that it is 1b, that's the GCF. And then we're going to factor the b out. But you see this negative sign right here? We have to factor it out too, because remember, we don't want there to be a negative in the leading coefficient. So this would be negative b that we're going to factor out. So this is the GCF. A negative divided by a negative is positive. Remember, you're subtracting the exponent, so it's 2 minus 1. So negative, and the b's become 1, so you have 6 on the end. This is what I'm training you guys to look for, are these negative signs. It will help you so much when you take pre-calculus. So this next one, which is number 8, is similar to a problem I was asking during the interviews. So if you haven't had yours yet, you will definitely have one. Okay, so is the polynomial in standard form? So the answer is yes. It is, because we've got the highest power and then we're going down. So that is in fact in standard form. Next thing we're going to check is what is the greatest common factor. So just to make sure we're all on the same page, it is 1m. That is the greatest common factor. And then we're going to check, is the leading coefficient negative? It is in fact negative, so this is negative. So we're gonna have to factor that out. So the GCF you're factoring out is negative, right? It's negative, and then it's m. And all the exponents are 1 right here. You can just think those in your head if you want. I won't mark you down for that unless you're getting this factorization incorrect. So negative m is the GCF, and then we're going to simplify everything down. So this is positive. You got to be careful of your signs. And positive divided by a negative is a negative. And then you just have 1m left. Positive divided by a negative is a negative, and then the m's become 1. Yay! Now you have to try to factor what's inside. It will not always work, but you definitely have to try it. So I'm going to do the X method, and then I'm just going to work it out. There's that invisible one, so I have that invisible one here. And remember, making that list is a good idea, but this one I think is pretty fast. Most of you would see it right away. The A term is 1, and so your final answer will be hopefully after 3 days of factoring, you have gotten more confident about what you're doing. Okay, pause the video whenever you need to, okay? Okay, number 9. So hopefully you see, even as I'm writing this out, and you're pausing the video when you need to, but even as I'm writing this out, everybody should be checking 2 things. What's the GCF, and is the leading term negative? I'm going to repeat it. What's the GCF, and is the leading term or coefficient negative? So this time, the leading coefficient, which is 5, is not negative, so I don't have to worry about negatives. But the GCF is 5. You have 2 parentheses that are exactly the same. So I would like you to start writing these 2 parentheses as a square. So this is your final answer. So these 2 parentheses are a perfect square. So this factorization is a perfect square, meaning the 2 parentheses are exactly the same square. Okay, we're back to GCF, and I know that it's 10, and I'm gonna actually show you what is incorrect first. So I would not write down what is incorrect when you're doing this problem. Okay, just watch it, and then I'll go back and correct it. I'm gonna show you what people do wrong on the test. They get really excited, and they go, oh, it's the difference of squares, I got this. And then they go, they're really excited because they think, oh, yeah, cool, easy. And then I mark it wrong. So I'm like, nope. So what's wrong? This is what's wrong. What's incorrect about this problem is that the student did not look for the GCF. So the answer that was provided when it was incorrect was not completely factored. So you should always ask yourself, what's the GCF? Okay, do not forget the GCF. And then what's the next thing you're gonna ask? Is the leading coefficient negative? Those are the first 2 things that you should be asking yourself and explaining to me in the interviews or the verbal test you're taking. So I don't have a negative, so I'm good to go, but I do have a GCF. And this time, my GCF, let's check it out. See, I'm going to try 2. Okay, right? So if you see that it's bigger than that, great job. But I'm gonna just do 2 and see what I get. 50 is not a perfect square. So I'm gonna try again and try 4 because 4 is the next even number. So I'm trying to teach you the process of what you should be thinking about as you're doing the problems. Okay, this one you're definitely going to want to write out. So the GCF, I'm going to try to see, hey, is it 4? 2 was too small. And then I'm going to factor it out. (64) divided by 4 is 16. And then hopefully you recognize right away that these are all perfect square terms. So 25 is a perfect square, b squared, and 16 are all perfect squares. I do have a difference, which is the difference of squares. And so I can do this quickly. And that is your final answer. And you do not write it as a perfect square like the previous problems because one of them is negative and one of the signs is positive. So you have to keep them separate. All right, what's next? Nothing, so that's fantastic. Okay, so make sure you're getting caught up. This was a much faster video. The reason why I'm saying you should take advantage of this time to work right now. Don't wait until Sunday at 9 p.m. because tomorrow is going to be your first super challenging day in class because we're going to be doing a thing called sum and difference of cubes. And that's tough for students. It's the first time you've ever done it. So we are moving on to real math-free content tomorrow. Okay, thanks, and I will see you later.